So we have to prove time of ascent is equal to time of descent. Ascent means something going up, descent means something coming down. So let's take the scenario wherein something is going in the upward direction. So if I have a ball with me and if I throw this upward, obviously I will throw with certain amount of velocity, and that velocity will be initial velocity that will be denoted by u meters per second. When I actually throw this ball in the upward direction, it reaches at the top and the final velocity becomes 0 because it stops at the top. So v is equal to 0 meters per second. The time that it takes to reach up, that is the time of ascent, will be considering as t1. Now, when the ball was actually moving up, final velocity became 0. That means whenever something goes up, its velocity decreases. And whenever velocity decreases, that type of acceleration is called as negative acceleration. So instead of g, we will take minus g. So if we substitute all these values in the first equation of motion, we have first equation of motion as v is equal to u plus at. So instead of at, since this motion is vertical, we write g instead of a. So v is nothing but 0. So we write 0 is equal to u remains u, right? So u is u plus g, but we have minus g, so it becomes minus g and t becomes t1. We have to find the value of t1. So what we do is we take minus gt1 on the other side. So what we obtain is gt1 is equal to u. So what happens is g comes to the right hand side and goes in the denominator. So we have t1 is equal to u upon g seconds. So this is equation number 1, or t1 is nothing but time of ascent, which is equal to u upon g. Now let's consider the other scenario, that is during descent. Now during descent, we know that object is in our hand, and we actually are going to just leave the object. That means the initial velocity of the object in our hand is actually equal to 0. And obviously when it goes down, it will take certain amount of time. So this time the time of descent will take t2. Now when this ball actually moves down, obviously it will reach the same velocity with which we threw it in the upward direction. And that initial velocity was nothing but u, remember? So this time the final velocity, which is v, will be equal to the initial velocity in the first case. That means v is equal to u. U is the initial velocity during ascent. And in this case, the velocity will increase. That is the reason g will be positive g. Again, we use the same equation, that is v is equal to u plus gt. Now, in this equation, v is equal to u plus gt, we know that v is equal to u. So we write u is equal to, what is u? The value of u is 0. So we write 0 plus g, and t2 this time is the time of descent. What we have to obtain is nothing but t2. So u is equal to gt2. So g goes on the other side and we write t2 is equal to u upon g. Now this is equation number 2. Now let's compare equation 1 and equation number 2. If you compare them, you can see that the right hand side is same. Since the right hand side is same, left hand side is also the same. That means t1 is equal to t2, which simply means time of ascent is equal to time of descent.